This is part 3 for the topic steady electric currents. And in this video, we are going to introduce Ohm's law. The last equation we derived is actually the point form of an important concept in electrical engineering that we are all familiar with, which is Ohm's law. And this law states that the current density in a given material is directly proportional to the applied electric field, related by the conductivity of the material. This implies that for certain materials, the ratio of the current density to the electric field that produced it is constant. However, Ohm's law is only valid for certain materials, and these materials that obey Ohm's law are called linear or ohmic materials, and those that do not are called nonlinear or non-ohmic materials. The conductivity of an ohmic material is measured in Siemens per meter and is the reciprocal of the resistivity ρ. The resistivity is the reciprocal of the conductivity, and it is a measure of how strong a material opposes the electric current. Every ohmic material has a characteristic resistivity that depends on the properties of the material and on temperature. The unit of resistivity is ohm meter. Here shows a list of the resistivity of common materials. The resistance of an ohmic material is related to its resistivity in that it is also the opposition of the material to electric current. The difference between resistivity and resistance is that resistivity is an intensive property, which means that it is a property of a material that does not depend on the size or the amount of material, as opposed to resistance, which is an extensive property. By manipulating the current form of Ohm's law, we get another form and show that the ratio of the voltage to the current is constant. And this constant is the resistance of the material, given by ρ times L divided by A, where L is the length of the conductor and A is the cross-sectional area, and ρ is the resistivity of the material. The unit of resistance, R, is ohm, named after George Simon Ohm. Given a conductor having a length dl, the resistance can be derived from Ohm's law using field quantities.